students, welcome to today's lecture. In today's lecture, I am going to discuss about the properties of modular arithmetic. Well, in the last class, we have discussed about the property, this congruence. Yes, before moving to congruence examples, one must know properties of modular arithmetic. In brief, in short, I am going to explain these properties. First one, A is congruent to A mod M. Yes, whenever A and B are equal, then we call them as A is congruent to A mod M. Second, A is congruent to B mod M and B is congruent to C mod M, then A is congruent to C mod M. Yes, basic your algebraic properties, those holds good here. Yes, A is congruent to C mod M and B is congruent to C mod M, then A is congruent to B mod M. Next one, A is congruent to B mod M, then for any C, A plus C is congruent to B plus C mod M whenever you add any integer. Yes, if A is congruent to B mod M, then for any C, A is A plus C and B plus C, it has repeated. Then A is congruent to B mod M, then for any C, A into C is congruent to B into C mod M. Next one, if AC is congruent to BC mod M and D is GCD, then A is congruent to B mod M by D. Yes. If next one, if AC is congruent to BC mod M and M is a prime number, then A is congruent to B mod M. If A is congruent to B mod M and C is congruent to D mod M, then A plus or minus C is congruent to B plus or minus D mod M. And next one, if A is congruent to B mod M and C is congruent to D mod M, then A into C is congruent to B into D mod M. Next one, if AC is congruent to B mod M and C is congruent to D mod M, then AB is congruent to B mod M. Next one, if A is congruent to B mod M, then AN is congruent to BN mod M. If GCD of M and N is 1, then A is congruent to B mod M and A is congruent to B mod N, then A is congruent to B mod Mn. If AB is congruent to 1 mod M, then A is inverse of B and B is inverse of A. A and B are inverses of each other. These are the few simple properties of modular arithmetic which we are going to use while solving the examples of this. And now we'll move on to the next section, modular exponentiation. As I mentioned, before solving your congruence examples, one must know what you mean by modular exponentiation. Yes, the word itself tell you what it contains. It contains modular plus exponentiation. Means it contains modular plus exponents. Yes, so the modular arithmetic is applied over your exponents. Yes, so this is what? This is a type of exponentiation performed over modulus. That is what? If A is A raised to B mod M means what? This mod M is applicable for whole A raised to B, not only A, it is for whole A raised to B. You can write this as well, A raised to B in the bracket mod M, so that it implies what? It implies mod M is applicable for whole A raised to B. So now we'll check using simple examples how you can perform such type of examples, how you can solve the exponents. Yes, you can solve larger power, you can solve smaller power using these exponentiation method. But in this video, I am going to explain you how to solve such type of examples by taking very simple examples. And do not try to compute these modular exponentials using calculator, because it is very easy method to calculate without calculator using this modulus. And also I am going to show you different methods. You can adopt whichever you can feel easy to compute such examples. Let us take um, some simple examples. Yes, those are, we take two examples first. 23 raised to 3 mod 30. Yes. Consider this example first. How you are going to solve this example? You can directly multiply 23 three times and divide it by 30. Yes. It will be a bit larger example, larger whenever you multiply 23 three times. You may get higher power terms also, but in your calci you can't get all the higher power values. Yes, it is restricted for some digits. Yes or no? So using this modular arithmetic, you can compute any highest large power using your modular arithmetic. Whenever you get such examples, what we have to do? First we have to concentrate on the term that is without power. Yes, without power means what? It is 23 mod 30. First concentrate on this one. Whenever 23 mod 30 is, what happens when 23 mod 30 is nothing? 23 is congruent to mod 30. What is the remainder? What will be the remainder? 23 is mod 30 means, since 23 is less than 30, all of you know, whenever the numbers are less than this mod m value, the remainder is itself. Yes? You can get a remainder as either 23, or else what is one more possibility? Remainder is either 23, or else you can make it to exactly 30. Whenever you add 7 to this, you will get a 30. Yes, then it is divisible. Yes, then only remainder will be 0. Means what? What will be the remainder here? Because our general form is A is congruent to B mod M. Our B is what here? It is the remainder. So we have to add 8 for this example. We have to add 7. So to add 7 means B must be minus 7. Means what? Either you will get a 23 as a remainder, or you will get a minus 7 as a reminder for this example. Yes. Now we have to choose among these two. You can take positive or negative values, but at the last, whenever you write the answer, remember you have to take it as a positive. If we get a negative also, we have to convert this positive. We'll show you how to convert that negative value to positive. Yes. Now among these two, either 23 is a remainder or minus 7 is a remainder. You have to choose smaller one. I will choose minus 7. So 23, and you can write 23, or else you can write minus 7. So in the previous class I have explained you why we are going to use this congruent instead of this equal to, because in real mathematics 23 is not equal to minus 7, but in congruence now we have shown this 23 is equal to minus 7. In place of 23 you can write minus 7. That is what the biggest difference of these modular and this equality. Now we'll write this in place of 23. Now write, I am going to use minus 7 because it will be easy, smaller number to take the powers. So minus 7 raised to 3 mod 30. Yes. Now what is minus 7 raised to 3? Minus 7 raised to 3, you can write it as minus 7 square into minus 7. What we did? We used the property of exponential. Bases are same. You can add the powers. Yes. Now minus 7 square is what? Plus 49 into minus 7 mod 30. 49 minus 7. 49 minus 7 is what? It is minus 133 30. So now whenever you divide this minus 133 by 30, what happens now? If you want, for this example, I am going to explain you. So minus 133 divides 30 means 120. Bigger number minus 133 plus 120. So your remainder is minus 13. So it will be minus 13 mod 30. What happened now? Now you have got a minus 13. One thing always you should keep in mind that the last answer remainder should be positive. So we need to convert that negative integer to positive. How? We have to add these two numbers minus 13 and plus 30. Addition means what? When you add these two numbers, what happens? Minus 13 plus 30 is what? Plus 17. So this is the answer. Therefore, 23 raised to 3 mod 30 is equal to 17. If you want to check this by calculating 23 raised to 3 power, the value, whatever value will get divided by 30, the remainder will be use the Euclid's algorithm. You can find the value is 17 only. Yes. Next, we check one more example. 51 raised to 500 mod 30. Yes. As I said before, we have to concentrate first on the simpler one, means that the number with the power 1 only. So 31 mod 30. So 31 mod 30, when 30 divides 31, the remainder will be obviously 1. So it is 1 mod 30. Now what you have means what now? 31 is equivalent to 1 now. Yes. So in 31 raised to 500 you have, for 31 mod 30 you have 1 mod 30. This means what? For 31 raised to 500 mod 30, you can write 1 raised to 500 mod 30. 1 raised to 500 is what? 1. So 1 mod 30. So what is the answer? So 31 raised to 500 mod 30. Whenever 30 divides 31 raised to 500, the remainder will be 1. Hope you have understood. Let's see one more. Suppose 242 raised to 329 mod 243. If you have a such type of example. Yes, what we will do? As I said before, you have to take the term with power 1 first. So 242 mod 243. So now, as we have seen before, either the remainder is, since 242 is smaller than 243, remainder is 242, or else you have to add, make this term which is divisible by 243. Means what? We have to add 1 for this. To adding 1 means what? That is a minus 1. Yes, you have to add 1 means it will be divisible by 243. So the remainder is either 242 or minus 1. The procedure what we have followed, we have chosen the smallest value. Yes. Now in place of 242, I will write minus 1 mod 243. Yes. Then what it implies? 242 raised to 329 mod 243 can be written as minus 1 raised to 329 mod 243. Now, since minus 1 raised to odd power, it is an odd power, then you will minus 1 raised to any term. Even term it becomes plus 1, odd term it becomes minus 1. can use this, or else you can split up this. Minus 1 raised to 328 into minus 1 raised to 1 mod 243. Even power it is plus 1 into minus 1 again minus 1. So you will get minus 1 mod 243. As I said, we can't keep this negative term, that's why add these two. Whenever you add these two, what will be the answer? Minus 1 plus 243 is plus 240. So what is the answer? 242 raised to 329. When it is divided by 243, your answer will be 240. This is reminder. If you want, we'll check one more example. I will show you this one. 11 raised to 7 mod 13. Yes. Now, when you compare with the example, so I will write it as 11 raised to 7 mod 13. Yes. 11 mod 13. 11 mod 13. You can write this problem like this also, up to 7 times. 11 mod 13. 11 mod 13. 11 mod 13. 1, 2, 3, 4, 5, 6 into 11 mod 13. Yes, this is one method. 11 mod 13, 11 mod 13, 11 mod 13. Yes, or else directly in the previous case, what I did, I used to take the first with the single power, power 1, 11 mod 13. Since 11 is smaller than 13, you may get a remainder as 11, or you may get remainder as, when you add 2 to this, it becomes 13s, then it becomes minus 2. You will get a remainder as 11 or minus 2. So, in place of this, you can use minus 2 or 11. So, now you may write 11 raised to 7 mod 13 as minus 2 raised to 7 mod 13, or you can write in place of 11 mod 13, you can write minus 2 minus 2 minus 2 mod 13, so on up to your 7 times. Yes, both are same. So 7 times you have to multiply minus 2. It is the same, minus 2 raised 7 only. Yes, or else you can write 7 minus 2 minus 2. What will be 7 times minus 2? 7 times minus 2 will be minus 128 only. Here also minus 2 raised to 7 is also minus 128 mod 13. Yes, when you divide this by 13, 128 minus 128, when you divide it by 13, you will left out with the minus 11 mod 13. Yes, since it is a negative term, minus 11 plus 13 is, so 11 raised to 7 mod 13 is equal to 2 is the answer. So, this is how to solve the examples with exponents. These are the very simple examples. If you understand such type of examples, then you can compute or perform any type of example with higher powers. You have to split up the powers and you can find the remainder of the smallest power, and you can put those values in the these models. Yes, this is how to find the exponents with the simple powers. In the next video, I am going to solve some examples with the higher powers, so that you are able to find the congruences of such examples. Till then, take care. If you are not yet subscribed my channel, do subscribe for your further notifications of other videos, and keep practicing. We'll see you in next class. Till then, take care. Thank you.